Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the surprisingly complex world of scaling WebSockets. It's not as simple as it seems.
Absolutely. I've always wondered about the behind-the-scenes magic of real-time applications. So what are some of the biggest challenges in scaling WebSockets?
Well, one major hurdle is handling deployments gracefully. You can't have users noticing your deployments, right? The article highlights a clever approach using a phased rollout with 503 responses and a custom WebSocket close message to manage reconnections smoothly. It avoids a thundering herd effect by introducing random delays.
That's fascinating. A 25-second window for server replacement, plus a random delay for reconnections. That's smart engineering to minimize disruption. But what about the managed services? Don't they handle this automatically?
Not always. The article points out that some managed services wait for all requests to finish before shutting down servers. With persistent WebSocket connections, this can lead to significantly longer downtime than expected. A real gotcha.
I see. So it's not just about the deployment process itself, but also about how the managed service interacts with long-lived connections. What other key aspects did the article cover?
Another crucial point is establishing a consistent message schema. They use a 2-byte type prefix for message categorization, super efficient and scalable, allowing for 65,536 different message types. They also use delimiters instead of JSON for faster encoding and decoding.
That's a clever optimization. Using delimiters instead of JSON is a nice touch for performance. It's all about those small efficiencies that add up at scale, right? What about connection reliability?
Exactly. The article emphasizes the importance of detecting silent disconnects using heartbeats. They send ping-pong messages every 30 seconds, and if a response isn't received within 45 seconds, they assume a disconnect and reconnect. It's a simple but effective mechanism.
Smart. A simple ping-pong system is often overlooked, but it's essential for maintaining reliable connections. What about network restrictions? How do they handle those?
They use server-sent events, SSE, as a fallback mechanism. Since SSE is HTTP-based, it's less likely to be blocked by restrictive networks. It's not as performant as WebSockets, but it provides a decent alternative. It's a good backup plan.
That's a practical solution. Having a fallback mechanism is crucial for robustness. The article also mentioned some other challenges, didn't it? Things they didn't fully address?
Yes. They mentioned the lack of standard tooling for WebSockets compared to HTTP. Things like rate limiting, data validation, and error handling often require custom implementations. Caching responses is another challenge. There's no standard way to cache WebSocket responses like you can with HTTP. And finally, per-message authentication is crucial for security.
So while WebSockets offer incredible benefits for real-time applications, scaling them effectively requires careful planning and a robust architecture. It's not just about the technology itself, but also about handling deployments, managing connections, and addressing potential network issues.
Precisely. It's a complex beast, but the rewards of building fast, real-time applications are well worth the effort. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the hidden complexities of scaling WebSockets. Have a great day.
Bye-bye.